In the infinite mystery of the cosmos lies hidden secrets in the void, where the divine particles dance to illuminate the universe. And the Higgs boson bestows mass upon matter. Antimatter, holding opposite qualities, roams, a part of the enigma drifting through space. Within the vast empty expanse of the cosmos, stars and galaxies emit faint glimmers of light. Yet amidst that light, tales still hidden guide us deeper into the unknown. The sight of neutrinos passing through black holes is a glimmer of hope traversing the universe's heart. Though the universe stands on the brink of judgment, scientists carry the torch of knowledge forward. The mysteries of the universe resonate deeply within us as we discover ourselves within its depths, lost in the wondrous beauty of the cosmos, continuously seeking new tales to unfold. Today, in the 20th session of our Introduction to Cosmology, we'll delve into the mysteries of the universe. We'll explore topics such as the God particle, antimatter, the vast voids of space, neutrinos, and counterarguments against the final judgment. Subscribing, liking, and turning on notifications greatly support our video production efforts. Higgs particle, the particle of the gods, that which is all. The Higgs particle, discovered in 2012 at CERN's Large Hadron Collider, LHC, is a fundamental particle in physics. It is the last particle discovered in the Standard Model and is considered one of the most significant events in modern physics history. It assigns mass to all fundamental particles existing in the universe. In other words, without the Higgs particle, all the matter as we know it could not exist. Role of the Higgs particle, the origin of mass. There are various particles with different masses in the universe. Fundamental particles such as electrons, quarks, WZ bosons, etc., possess mass, and this mass arises through interactions with the Higgs particle. Thus, the Higgs particle plays a role similar to that of a god, controlling the mass of all particles existing in the universe. Analogy: let's liken the Higgs particle to honey. Honey itself has weight, but when mixed with other substances, it imparts mass to them. Similarly, the Higgs particle interacts with other particles, bestowing mass upon each of them. Importance of the discovery of the Higgs particle. The discovery of the Higgs particle is important for the following reasons. Completion of the Standard Model. The Standard Model is a theory that describes the fundamental particles constituting the universe and their interactions. The discovery of the Higgs particle played a crucial role in completing the puzzle of the Standard Model. Possibility of new physics. The Higgs particle can serve as a key to exploring physics beyond the Standard Model. Studying the characteristics of the Higgs particle is expected to help understand phenomena such as dark matter, dark energy, etc., which are not explained by the Standard Model. The Higgs particle is a particle that interacts with a special energy field called the Higgs field. The Higgs field exists throughout the universe, and when particles interact with the Higgs field, they acquire mass. Particles without mass move rapidly like light. However, when they interact with the Higgs field, their speed slows down, and we perceive this slowdown as mass. Particles that interact more with the Higgs field have larger masses. For example, electrons have greater mass than quarks because they interact more with the Higgs field. Why is the Higgs particle called the particle of the gods? The Higgs particle is called the particle of the gods for the following reasons. Role in bestowing mass to all particles. As mentioned earlier, the Higgs particle bestows mass to all particles. This is akin to the metaphor of a deity creating everything in the world. Advancement in understanding the universe. The discovery of the Higgs particle has advanced our understanding of the universe. This is a significant event in the history of science, and it's one of the reasons why the Higgs particle is referred to as the particle of the gods. Completion of the Standard Model. The discovery of the Higgs particle played a crucial role in completing the Standard Model. The Standard Model is currently the most successful physics theory we know, and the Higgs particle can be seen as the final puzzle piece of this theory. Opening new horizons in scientific inquiry. The discovery of the Higgs particle opened up new opportunities to explore new laws of physics. By studying the characteristics of the Higgs particle, we can gain more information about the fundamental structure of the universe. Interesting facts about the Higgs particle. The Higgs particle exists for an extremely short period and then decays into other particles. The Higgs particle is not yet fully understood, and scientists continue to study it. The discovery of the Higgs particle awarded the 2013 Nobel Prize in Physics to Peter Higgs, François Englert, and Robert Brout. Research on the Higgs particle. Research on the Higgs particle continues even after its discovery. Scientists are studying the characteristics of the Higgs particle to find answers to questions such as: does the Higgs particle exist alone, or are there other Higgs particles? How does the Higgs particle impart mass? How is the Higgs particle connected to other laws of physics? research on the Higgs particle will play a crucial role in understanding the fundamental structure of the universe. Antimatter, the mystery of the universe. Antimatter is a substance with properties completely opposite to those of the matter we are familiar with. When matter and antimatter with the same mass meet, they annihilate each other, releasing tremendous amounts of energy. This energy is so powerful that it could obliterate the entire solar system with just 1% of the sun's mass. However, despite its immense power, antimatter is scarce in the universe, remaining one of the mysteries of the cosmos. Characteristics of antimatter. Opposite charge. Matter and antimatter have the same mass but opposite charges. For example, the antimatter counterpart of an electron, called a positron, has the same mass as an electron but carries a positive charge. Annihilation. When matter and antimatter meet, they annihilate each other, converting into energy. This energy is emitted in the form of light and heat. The energy is equivalent to twice the mass of the matter and antimatter. Rarity. Antimatter is almost absent in our surroundings. Only trace amounts of antimatter have been detected in a few space missions. The origin of the detected antimatter is still unknown, and it exists in minuscule quantities. Mysteries of antimatter. Why does only matter exist? According to the Big Bang theory, matter and antimatter should have been created in equal amounts. However, in the present universe, matter is prevalent, and antimatter is scarce. The reason for this imbalance remains unexplained. A universe of antimatter. There's a possibility that there exists a universe made entirely of antimatter. If so, it would operate under entirely different physical laws than our universe. Contradiction with the Big Bang theory. According to the Big Bang theory, matter and antimatter should have been created in equal amounts. However, in the current universe, only matter is abundant, while antimatter is almost absent. This fact contradicts the Big Bang theory. Asymmetry. There's no clear explanation for why only matter has persisted and why antimatter has vanished. This is linked to the mystery of the universe's asymmetry. Research on antimatter. Scientists are conducting various studies to elucidate the characteristics and existence of antimatter. Antimatter production. Facilities like CERN's Large Hadron Collider, LHC, are artificially producing and studying antimatter. Antimatter exploration. Research is underway to detect antimatter in space. Applications of antimatter. Antimatter holds potential applications in fields such as medicine and energy. Significance of antimatter research. Understanding the early universe. Research on antimatter could play a crucial role in understanding the early history of the universe. It could shed light on events that occurred immediately after the Big Bang. Discovery of new physical laws. Antimatter research could lead to the discovery of new physical laws. Existing physics cannot fully explain the rarity of antimatter, necessitating the need for new physical laws. Energy source. Antimatter, with its immense energy release, holds potential as a future energy source. However, the technology to produce and store antimatter is currently very challenging. Interesting facts. In 2016, CERN successfully created antimatter hydrogen atoms for the first time. Antimatter could be utilized in cancer therapy. Concepts of space travel utilizing antimatter are within the realm of imagination. Antimatter still poses many mysteries, but through the ongoing research efforts of scientists worldwide, these mysteries are gradually being unveiled. Currently, scientists worldwide are engaged in research on antimatter. Experiments are being conducted at facilities like CERN's Large Hadron Collider, LHC, to create and study antimatter. Additionally, various studies are underway to uncover the origins of antimatter. Antimatter is one of the mysteries of the universe, raising many questions for us. Research on antimatter is crucial for understanding the early history of the universe, discovering new physical laws, and exploring potential future energy sources. The vast void of space, existence and significance. Contrary to common perception, most of the universe is comprised of vast empty spaces. The regions where stars and galaxies exist make up only a tiny fraction of the entire cosmos, with the rest being largely vacuum-like voids. These expansive voids hold significant meaning in cosmology and physics while harboring many mysteries. Characteristics of empty space. Vastness. Empty space is far larger than what we commonly imagine. Even the nearest stars are separated by distances of several light years, and between galaxies lie distances of millions of light years. Vacuum state. While not a perfect vacuum, empty space is filled with extremely low densities of matter and energy. Dark energy. Much of empty space is filled with an unknown form of energy called dark energy. Dark energy is thought to accelerate the expansion of the universe. Reasons for the existence of empty space. The Big Bang. According to the Big Bang theory, the universe began from a hot, dense state about 13.8 billion years ago. As the universe expanded, it gradually cooled, and matter condensed to form stars and galaxies, leaving behind empty space. Dark energy accelerates the expansion of the universe. As a result, empty space continues to expand over time. Questions surrounding the existence of empty space. Why does empty space exist? According to the Big Bang theory, the universe should have started with a uniformly high density. However, empty space exists in reality, which contradicts the theory. Nature of dark energy. While dark energy occupies most of empty space, its exact nature remains unknown. Research is ongoing to understand what dark energy is and how it operates. Significance of empty space. Cosmology. Empty space plays a crucial role in cosmological studies. By measuring the density of empty space and the amount of dark energy, predictions about the future of the universe can be made. Physics. Empty space could aid in the discovery of new physical laws. Understanding unknown forms of energy like dark energy may necessitate the formulation of new physics laws. Existence of life. Empty space may influence the existence of life. If empty space were too abundant, stars and galaxies wouldn't form, preventing the creation of environments suitable for life. Importance of empty space research. Universe expansion. Research on empty space helps in understanding the expansion of the universe. Understanding the properties of dark energy could help predict the future expansion of the universe. Early universe history. Research on empty space aids in understanding the early history of the universe. It could illuminate events that occurred immediately after the Big Bang. Discovery of new physics laws. Research on empty space could lead to the discovery of new physics laws. Current physics laws cannot explain dark energy, necessitating the need for new laws. Current status of empty space research. Scientists worldwide are conducting research on empty space. Using telescopes, they measure the density of empty space and study the properties of dark energy. Additionally, computer simulations are used to study the formation and evolution of empty space. The vast emptiness of space poses many questions for us and remains one of the mysteries of the universe. Research on empty space is essential for understanding universe expansion, early universe history, and the discovery of new physics laws. The mystery of neutrinos. Neutrinos are fundamental particles with no electric charge. They were first discovered in 1956 and are known to exist in three types: electron neutrinos, muon neutrinos, and tau neutrinos. Neutrinos have extremely small masses and interact very weakly with almost all forms of matter, making them exceedingly difficult to detect. Characteristics of neutrinos. Extremely small mass. Neutrinos have masses much smaller than 1/millionth that of an electron, making them significantly lighter compared to other fundamental particles. Weak interaction with matter. Neutrinos, having no charge, do not interact via electromagnetic forces. Additionally, they interact very weakly with strong nuclear forces. Near light speed movement. Neutrinos can travel at speeds close to that of light. Importance of neutrinos. Solar energy production. Neutrinos play a crucial role in the production of solar energy. They are generated in the core of the Sun during nuclear fusion reactions and help transport solar energy to Earth. Stellar explosions. Neutrinos are also significant in stellar explosions. Much of the energy released during stellar explosions is in the form of neutrinos. Cosmic expansion. Neutrinos can influence cosmic expansion. If neutrinos have non-zero masses, they could affect the gravitational potential contributing to cosmic expansion. Early universe history. Neutrino research is essential for understanding the early history of the universe. It could shed light on events that occurred shortly after the Big Bang. Discovery of new physics laws. Research on neutrinos may lead to the discovery of new physics laws. Current physics laws cannot fully explain the mass of neutrinos, necessitating the need for new laws. Future energy source. Neutrinos, due to their near light speed travel and weak interaction with matter, hold potential as future energy sources. Current status of neutrino research. Scientists worldwide are conducting research on neutrinos to answer questions such as: what is the exact mass of neutrinos? Are there additional types of neutrinos beyond the known three? How do neutrinos influence the process of solar energy production? Neutrino research will play a crucial role in understanding the fundamental workings of the universe. Neutrinos remain one of the mysteries of the cosmos, with their characteristics and roles not yet fully elucidated. Neutrinos and black holes. Neutrinos can pass through the event horizon of a black hole. The event horizon of a black hole is a boundary from which not even light can escape, but neutrinos, lacking electric charge and having extremely small mass, can traverse the tremendous gravitational pull of a black hole without being deflected. Black hole information paradox and neutrinos. The black hole information paradox suggests that all matter and energy sucked into a black hole are preserved indefinitely without any loss of information. However, if neutrinos can pass through black holes, it implies that some of the information absorbed by the black hole could be leaked out externally. This poses a fundamental challenge to the black hole information paradox theory. Research on neutrinos and the black hole information paradox. Currently, scientists are conducting research on neutrinos and their interaction with black holes, particularly regarding their potential impact on the black hole information paradox theory. Studies aim to understand what information neutrinos carry when passing through black holes and how this information may influence the theory. Significance of neutrinos and black hole research. Research on neutrinos and black holes plays a vital role in understanding the fundamental structure and laws of the universe. The fact that neutrinos can traverse black holes provides new insights into the characteristics of black holes and the issue of information preservation. Current status of neutrinos and black hole research. Scientists worldwide are engaged in research on neutrinos and black holes. Through various experiments and observations, they seek to elucidate the properties of neutrinos and black holes, shedding light on their interactions and implications for the universe's fundamental laws. Neutrinos' ability to pass through black holes poses a fundamental challenge to the black hole information paradox theory. Scientists endeavor to understand the universe's fundamental structure and laws through research on neutrinos and black holes. In the silent whispers of the cosmic winds, whispers of ancient secrets echo through time. In the dance of particles, the Higgs boson speaks, granting mass to the fabric of the universe. Antimatter, a shadow in the cosmic ballet, holds within it the promise of annihilation. Yet amidst the vast emptiness that stretches on, the cosmos holds its breath, waiting for revelation. Neutrinos, silent messengers from distant realms, drift through the void, bearing tales untold. In the shadow of black holes, where light fades to naught, the mysteries of existence await their unveiling. And as the universe approaches its final reckoning, the quest for understanding burns bright in our souls. For in the heart of every mystery lies a story waiting to be told, in the cosmic tapestry. Thank you for watching until the end.